Hello, Mr. Miller here, your online math teacher. Welcome to my channel. Today we're going to be continuing my video series on trigonometry, and in particular, looking at how you might use double angle identities in your pre-calculus class. Now, if you don't know what they are, maybe consider going and watching my video where I prove them, and I show you an easy way to recall them from the addition and subtraction formulas. But let's get going. So as always, if you like the video, hit like and consider subscribing. Let's go. So, just like any of the other identity problems you're going to get when you're studying trigonometry, your teacher is always going to ask you to prove different things with them. Whether you're using Pythagorean identities, addition, subtraction, double angle, power reducing formulas, you name it, your teacher's going to ask you to prove with it. So, let's start by looking at this example here. If you want to prove that 6x is equal to 2 times cosine squared of 3x minus 1, this is going to be an application of a double angle identity. Now, the reason I'm going to use the double angle identity is one, because my right hand side looks very close to a double angle identity, and I have things like 6x or 3x inside. And I don't see a very natural way to rewrite 3x as a multiple of 2, although I can with fractions, but usually your teachers won't put fractions there. But I can rewrite 6x as 2 times 3x. So what I'm going to do is I'm going to start with my left-hand side here. And I'm going to think of this left-hand side as cosine of 2 times 3x. So if you were to replace 3x by theta, we can then directly apply the identity. Cosine of 2 theta is equal to 2 times cosine squared theta minus 1. So 3x is just playing the role of theta here. So when I apply that, I end up with 2 cosine squared of 3x, because 3x is our theta here, minus 1, which is exactly the right-hand side, which you're trying to prove. So this is a very short, quick example of how you might prove something with a double angle identity. Now, it's a little bit trickier when you're using the double identities angle for cosine because you have 3 options. Go with the one that looks most like what you're trying to get to. And there's nothing wrong with if you work for a while and you're getting nowhere, going back to an earlier point in your problem and trying a different one of those double angle identities. But the good thing about if you're working with sines or cosine double angle identities, there's only one way you're going to do it. So now the second type of problem your teacher is likely to ask you to do is solve an equation where you need to apply a double angle identity. So maybe you want to solve sine of 2x is equal to 2 times sine of x. So what your instinct should be is, well, I'm not used to solving sine of 2x is equal to stuff, but I can rewrite that sine of 2x in terms of just x being inside our trig function. And I'm going to do that by applying the double angle identity. Sine of 2 theta is equal to 2 sine of theta times cosine theta. The only difference is I have an x inside as my variable and not theta. So again, I'm going to start by subtracting everything to one side, because that usually in these solving algebraically problems, you tend to move everything to one side. So it's one of either the left or right hand side of our equality is 0. And then you'll try to factor it somehow and set those factors equal to 0. So that's our goal here. So sine of 2x minus sine of x in this case is going to be equal to 0. Now I'll apply my double angle identity, but I have x instead of thetas. So I have 2 sine of x cosine of x instead of sine of 2x. I still have my minus sine of x. And now that's equal to 0. And I can clearly factor out the sine. So I factored out that sine to be able to get sine of x times 2 cosine x minus 1 is equal to 0. And now it's just like most of your equations you solve algebraically. If these factors multiply to give you 0, then one of the factors has to be equal to 0. So what we do is you can just take them both and set sine x equal to 0 and 2 cosine x minus 1 equal to 0, which is also equivalent to solving cosine x equal to 1/2. And the good thing is we know which values on the unit circle where sine will be equal to 0 and cosine will be equal to 1/2. Since sine is treated as the y coordinate on the unit circle, if we need to know where sine of x is equal to 0, it's just going to be equal to these 2 points on the x-axis. Angles that put us at those locations will give us sine of those angles equal to 0. So if we're looking for all our solutions between 0 and 2 pi, not including 2 pi, then we are going to pick up solutions of x being equal to 0 and maybe x2 being equal to pi from our factor of sine here. If I then do the same thing and move over to my cosine of x is equal to 1/2, you can remember that cosine is treated as the x coordinate on the unit circle. So if I'm looking what values are going to give me cosine of x is equal to 1/2, I know I'm going to get 2 solutions, because if you imagine a line right here that's like x equal 1/2, so, and this x is not the same x is in there, we would remember that these 2 angles between 0 and 2 pi are going to be an angle of pi over 3, that'll put me at the dot in the first quadrant, and then an angle of 5 pi over 3 that'll put me into the fourth quadrant. So I pick up 2 more solutions here at x3 is equal to pi over 3 and x4 is equal to 5 pi over 3. So these 4 values here are going to be all your solutions between 0 and 2 pi. So this is the second way you will be asked to apply it. Your teachers might also ask you to try to evaluate things with it, but probably not, because if any angle that you might want to evaluate that's double something you know is already on the unit circle, so you're not going to need an extra formula to evaluate it. So typically your teachers will probably ask you to algebraically solve equations with it, and they'll ask you to prove some trig identities with it. So I hope you found this video helpful. If you did, hit the like button and have an awesome day.